In the final part of Seeing Birkeland Currents, we will once more discuss the formation of the Gould belt and how this formation possibly left a big void known as the local chimney. We will then discuss how our movement through what is considered our local clouds might in fact be evidence of twisting helical Birkeland currents, and also looking at stars that sit behind and in front of us gives us this idea that they are indeed following a path rather than moving in straight lines, and how this may also potentially affect the brightness and the colour of stars themselves. But from that, one of the things, and that's kind of how I was talking about the supernova explosions, is again looking at this idea of the formation of the Gould belt. And it's one of the things that Wall pointed out in his email about his paper that he did on the 1987A supernova explosion, how you end up with that ring that expands away from it from an event that could be an electrical event, and I think I want to do something around how that is created, but then also the things that you talked about, the fact that those stars are bluer, and the fact that those stars then have, in this case, it would be a circular orbit because of that, the fact that they're sort of locked into that band of material that created them, and then potentially locked in to some sort of a field that is, well, is it expanding with them? I mean, they must be beyond what would have been the shell of the original Birkeland current, surely.
Yeah, well, I mean, the observations. That's one nice thing, is that, especially when the observations don't match their theory, that's how you can kind of count on them. But
yeah, but if we assume that so looking at the image here. So if we assume that the R filament comes down from here, and that some Z-pinch event caused that the Gould belt formation, some sort of an explosion caused that formation, then where the Gould belt now sits surely would be outside of what we would consider to be the extent of that single filament structure. It would have pushed outside of that boundary, is my question.
Oh, outside of the
original Birkeland current that caused the pinch.
Yeah, well, right. Well, that's usually like when you see like an image of a Z pinch with a torus. I mean, just the classical, like the Squatterman images.
Yeah.
Yeah, you can see that the torus is wider than, or can be wider than the whole, up and down Squatterman image. Yeah, because the torus isn't formed from. That's what I was trying to get with the pinches. Like they still try to make that a random event from the current filament, and it's not. If you understand that, the pinch happens where a filament maybe crosses through. That's the other important thing about the Gould's belt, that it's centered on, that ring is centered on the galactic plane. So that material for the belt can all be explained as coming from originally the galactic plane where that current went through it. So it basically...
So the hole it created, whereas I've got an image of...
Yeah, and that it even drags material from the galactic plane towards it. I mean, it can, if there's a radial electric field, then it can...
So that this void area would be... you don't really see the Gould belt so well in this, but the Gould belt would sit somewhere out here, wouldn't it?
Right.
Yeah, it's just a question whether that, because that ring of stars effectively is disconnected from this stream, because that stream would still be coming in here. Obviously we are part of that structure, But the question is, how does this, or is this just further out, and it just happens to be that structure is connected, but that's where that material ended up being pushed out towards. So the outer edges of that filament, I guess, maybe a bit like, where's that image of sort of here? I guess possibly it is just like we see, is the Gould belt just further out because the material's been sort of ejected in that direction, but that's still part of this much larger current structure. It just happens to sit on that edge. That's my question, really.
Yeah, I'm gonna have to get to. I mean, I know pretty much the local chimney and Gould belt dimensions and extension, but that Radcliff wave is pretty new, and I have to. What I want to find out is where basically what the closest point is in the direction of the closest point to us and the distance that they're getting for the closest point. I just want to see where that is actually, if they, I mean, to the extent that they have it mapped out.
I don't. You can't really see the data set in here. I'm sure you somehow can get hold of it, but it doesn't really tell you what. It doesn't even tell you what the star is, or then, well, it's not really a star, is it? It is a star. It's a star in front of a lump of gas. It just tells you
Right.
Taurus. But I'm guessing there must be a data set that has, because all of these have different names, I think. Yeah. See, that's Perseus. So they have labeled them. The closest one is this Taurus one. Unless you look at blue, but I don't think blue is part of their wave. Yeah. You've got the link to this, though, right? It's in.
Right.
Yeah. I don't know whether you'd get the data from. But anyway, that was sort of my question. So that's one thing I want to sort of look at, trying to explain again how this might form, and how from those extreme events, how you can end up with material that sits at this edge. And then the question is this still connected to that Birkeland current, or is this a separate structure that, I don't know, is siphoning energy from somewhere else? That would be the question, really. Is it stopped expanding because it's reached that outer edge, like here somewhere in this structure? So that's a question. That's my sort of mumblings on it. That's I would like to try and, even if we can't discuss it, even if we don't know, we will discuss it, but even if we can't answer it, I'd like to come up with different alternatives. Like, if it is, then this, and if it's not, then maybe this might be going on. Because for me, an interesting question would be, is if it's not, then what happens when that ring of star intersected and moved further out? Because the assumption is it was much closer and therefore moved further out. That's pretty traumatic, I would have said. That shockwave moving outwards across here. And if it's still expanding, then that could have ramifications for stars that sit further out. Or it won't move because it's reached the edge of as far as it can go. And if it moves any further, then the stars won't be powered anymore. But they may actually be physically held in place by that outer edge. But that's sort of my thinking on that, really.
Right.
Questions.
Yeah.
I don't have answers, but questions. But I'd like to do something around that as well. That's certainly. I think that's a lot of people are wanting to know more about the Gould belt and the formation and how it relates to the stars that sit here. When we look at Betelgeuse and other ones, they all sit on the edges out here. So does that affect it? And again, that's another thing, looking at how different stars get powered, and it's one thing to do how stars change, but then when we look at the dynamics of what we have here, how can we explain some of those different types of stars that we see? Is that to do with where they sit within a much larger structure of the Birkeland current? Is it to do with gas filaments that are they're intersecting or moving across? So that comes back to this idea that we have, independent gas moving to our movement, and that's still a question, I think. Because I come back to Wall's idea on super red giants, and you have the fact that the electron is somehow inhibited. The movement of the electrons into the star is somehow inhibited. But then how does that happen? Now, what causes that to happen? And for me, the only way that can happen, that's dust or some sort of neutral material, which is then absorbing those electrons. More likely dust, I would say. But that means it has to have moved into, so it's either fallen in towards the star from elsewhere, or the star has intersected a dust cloud.
Right.
And again, if we're talking about Birkeland current structures, how can you get dusty material that flows through that?
Right. Yeah, that's why I liked. Was it Priscilla? Am I saying the name right?
Yes. Her mapping of all the gases and stuff like that, and the movements
and even
of
just
those.
she even knows that just that even the sun, just if it did nothing other than ionize the dust, all of a sudden we have charged particles where we didn't before. That idea even is fascinating, even with the idea of a totally electrically neutral sun. I mean, the implications are
huge.
Huge for how our even our neutral environment would affect a net neutral sun is even like amazing in that. And then all the observations that we're changing radius in our gas cloud. Now, whether we leave it or not, again, that's the mainstream idea of us on a straight line path.
Yeah.
But the observation that we are changing radius in it, that, I mean, you can't really get away from that. The fact that, and we know that the things are changing here in our solar system. So.
Yeah, so there has to be some effect that our movement, the movement through, and I guess to some extent, I suppose that makes sense, because the neutral material, and even I guess slightly ionized material that sits outside of that Birkeland current, would still have a motion due to the electric fields around it, and even the neutral material, would have motion due to other forces on them. So when they intersect, I guess, these filament structures, they will get drawn in. Surely, but by, even if they're not attracted to the movement, purely by kinetic impact, you would start to see, and of course gravity, if we still hold true that gravity must act at this scale as well. I'm just for me there are a number of still open questions around how some of these stars change, that I think is important to understanding the structure and how we fit into this picture of where we are and why certain stars change, and potentially what the implication for us is, because there are a lot of people saying a lot of things about many things, doomsday scenarios, that I don't know whether they're all true. And
right.
I think understanding the mechanisms is more important than focusing on, what will or might not happen. And we see examples in terms of the stars that sit on the edges of some of these things, and I just have an unending supply of questions.
Right.
But anyway,
well, you saw that the one of Sirius in the local interstellar cloud, right, where that fits in that. If you look at images of the local interstellar cloud, where not that one so much, you might find another one where it looks more like a twisted filament. Yeah, that one, for example. that to me is the one that's most suggestive of, if you know that according to all the written records, Sirius went from a red star to a blue star around, what was it, 500 AD? Is that what
yeah. I think that's
and you see, and you see where it's knowing that its motion is actually towards, it's kind of in the direction of the sun. It's a little bit across the sky, but it has a radial velocity towards us. So in the direction we're going, it's even going faster. It's coming into that region. So
this region here you're talking about?
Yeah. So it's like, what it looks like to me, I see that as like a pinch right there where these two, what they're mapping is
this here.
Well, see, they're showing the local cloud and the G cloud.
Yeah.
And again, like I'm saying, you have to look at all these pictures where this one shows the more spiraling nature, but you lose the whole bigger picture of where they're going. The last one you had showed the more curving, long-term curving path. But the G cloud shown here and the local cloud, to me, I see a lot of evidence of those being a small scale, like Birkeland pair, that they're twisting around each other. And if you search sometime on just the G cloud alone, you'll see a kind of a general drawing of it, and it shows kind of almost like the G cloud going around the local cloud. But what I would suggest is that Sirius just was a red star, and when it moved into that pinch area where those things, where all this current came together, that's what fired it up. I mean, that would make sense from EU theory and the picture and what we know of its motion, where it is in those twisting clouds. That's what I suspect. And what's interesting too is if you look at like the story that they're trying to build in the EU community, is way before that, the sun was our solar system, whether it was our sun or one of the other planets. That the point was that we were we had a red star, not a bright yellow star. And we also were way before back in that region too. So you can almost see a story unfolding in the pictures there.
That's I hadn't really considered that. Yeah, that's an interesting. So if we map this one backwards, then it would be outside somewhere here. Or are we saying that where we're seeing a lack of material, that it is more dense? So it would be.
Yeah. So I mean, it seems like it's kind of more like in a pinch area now, and it's a blue star now, where you would expect current to be kind of drawn in. So
Yeah, I'm just trying to work out, where are we suggesting therefore that because you're saying it's a pinch structure, is that because you're seeing less material?
I see kind of like, it's not as clear again in this image, but you can almost see like along kind of one filament along the direction we're going, and then kind of one almost vertically.
Yeah, so this hit along here, kind of and then there. That was yeah. And it sort of goes up here.
Right.
And there's it's almost like there's two edges to this. So there's an edge that goes down here, and then an edge that would be the opposite if these are twisting. You know, if that's just on the opposite side of a twisting pair, maybe that's the center. Is that what you're suggesting? The center in between the two.
Right. Yeah. Like mainstream observations would say that we're kind of on the surface of the local cloud and headed into the gap between us and the G cloud. But both of those are, I mean, even in the mainstream wording, you can't see it in this image very well, but they say they're filamentary clouds. and they're interacting filamentary clouds, and we seem to be at the transition from one cloud to the other or something. But
what we would say is that that's not the case, that in fact our path would just continue along that edge anyway, because that's We're just following that path, just like Sirius will continue to follow that path.
Right.
So
and
our
that's
motion
where
is just in this direction because that just happens to be at this point the instantaneous, but actually we're going to curve sort of around here and up there.
Right. Well, yeah, that's where, like in that other picture with the one that showed that you had right before this with the picture of Altair and out ahead of us, that the most important thing in that picture, that's what I wanted to get when I first started looking at the Starry Nights software, is that the mainstream knows that the sun is moving. In their own papers, it says we're skimming the cloud surface, and you can kind of see it there.
Yeah.
So what I wanted to do is look at Altair's motion, and sure enough, if you go to the center of curvature of that, which is about where Arcturus is, Altair has the same motion. It's the arrow that's pointing to Altair. That's just pointing to Altair, but that turns out to be pretty close to its direction of motion too. So in other words, that star also is skimming the cloud surface. So that makes it really a coincidence if our sun is supposed to just keep going off on the tangent like they think it's going to do, then that makes it very curious that Altair is also moving on tangent, skimming it and going to leave off on a tangent too. No, that's, again, there's been no long-term observations of thousands of years that can say that and that's what we're stuck with in modern times. Ancient people did say that we're circling on all these different scales, other stars, but the mainstream jumped to when we finally got away from the geocentric idea, and then got to at least heliocentric. Then it was center of the galaxy. That's the next big one, which puts us on this same straight line they show there. On the local scale, we're just all on straight line paths, but nope, that.
Yeah, you have your motion. You're going to get it once, and once you've got it for the rest of eternity.
Right.
Unless you have a collision, in which case it's very random, and then we can't predict where you came from. Also known as Betelgeuse.
Right.
Yeah. Wow. Well, thank you very much for your time, Jim. This has been a fascinating insight into, and I hope people enjoy helping to see how these structures sort of fit together, and helping to see how the Birkeland currents might structure themselves, and how we see those in those images, and then some of the problems with those images, and the fact that we don't have the answers to all of it. There are indeed many mysteries out there that are still awaiting for us to sort of come up with ideas that explain them in a way which is understandable to us. But I think certainly looking at a lot of those things, our explanation in a lot of those cases makes more sense than the mainstream explanation at the moment. But anyway, sorry, I waffle. Thank you very much for your time, Jim.
Oh, thank you for all your work on all these videos, actually.
I have to say, it's been an incredible journey, considering that I started this a year ago. Well, it's over a year ago now, actually, and yeah, honestly, I never started it thinking that it would lead to anything really, just something that I enjoy doing, and here we are. We're still here, and we're still making videos, and they still make sense.
Yep.
And I think you're a big part of that too, I have to say, Jim. I think you poke the right buttons for me to go, oh yeah, that's a good thought, and that's an interesting idea, and off we go doing it. So big thank you to you as well. Now that concludes the Seeing with Birkeland Currents mini-series. This may well be something that we come back to. One of the things for me, the takeaway that I am currently working on is doing an episode, sort of a deep dive into understanding Birkeland currents, our current sort of concepts behind it, so the Bessel function. I know I've done sort of an outline video covering the basics of Birkeland currents, but I think it needs to be taken one step further, because there are gaps in the current models, and I want to try and highlight those, and also sort of explain how the models work, and then explain where we need to focus more attention to flesh out those current models. Lastly, if you've enjoyed the video, then please don't forget to leave a like. If you haven't subscribed, then consider subscribing. And finally, a massive thank you to all my Patreon supporters. As always, be brave, be curious, the truth is waiting for us. Until next time.